Okay, this is the third video, review video for Unit 2. And next up is our transformations. So I want to talk about this in the context of three different types of problems. So let's first talk about, say we have some function, and on this function, so f of x is a function, and we know that f of 3 equals negative 5. So what do we know there? Well, we only know a point. We know that the x coordinate of the point is 3, and the y coordinate is negative 5 on this particular function. So I might ask you, where does this point go given the following transformations? So say we had f of, let's do something simple first, minus 5. Something like this. Okay, so in terms of the transformation effectors, anything inside the function here, and that would be the x plus 3, is referred to as a domain effector. It is affecting the x coordinates or the domain of the function. And anything outside of f, which in this case is are 2 and negative 5, those are the range effectors affecting the y values or the range of the function. So again, we only know that f of 3 equals negative 5. So when I think about the domain transformation, I always talk about, and you've heard me say, reverse order of operations. Well, the reason being, I want to ask myself in this case, what do I have to put in for x so that I'm evaluating f of 3? Because that's all I know. So I'm going to set inside the function, which is this x plus 3 equal to 3, and solve for x, so x being 0. And notice if I plug in 0 for x with this transformation, I'm evaluating f of 3, which is the only thing I know. So I wanted that to happen. So this 3x coordinate now has gone to 0. And for many of you who remember transformations from last year, you might remember that, x plus 3 means I don't shift right 3, it means I shift left 3. So that's what brings me to 0. And that's why, again, you're thinking that reverse order of operation because I want to figure out what I have to put in for x so that I'm evaluating f of 3. So my x coordinate has gone to 0. And now I know when I plug in 0, I made it such that I'm evaluating f of 3. That was the point. And so coming out of the f function should be that y coordinate, which is negative 5. And so this now transformation says I'm going to multiply the y values by 2, so vertically stretch it. So I'll get negative 10 and then subtract 5, which will get me negative 15. So again, I think it's helpful to think domain transformation, reverse order of operations, range transformations, you're following the order of operations. Let's do another one. What about, let's do something slightly more complicated. Let's do negative 3 f of negative x, let's do plus 4 plus 8. Okay. So again, actually, let me make it a little bit more interesting. Let's do maybe negative 2x plus 4. Okay, the domain effector is the negative 2x plus 4, so that's impacting my x coordinate. And so when I think reverse order of operations, I'm thinking, what is happening? What do I need to plug in for x so that I'm really evaluating f of 3? And if we want to think graphically what's happening, notice here the first thing I'm going to do is subtract 4, which if we're talking about the graph, that means left 4. So I'm subtracting 4 first. So that brings my x coordinate now to negative 1. And then I'm dividing by negative 2, which is kind of doing two transformations at once. The negative is reflecting over the the y-axis, and the dividing by 2 is I'm a halving that x coordinate. So I get 1/2. So again, reflect over y-axis. So negative x values become positive, and positive would become negative, and then x coordinate gets halved. So it's a horizontal shrinkage. All right, so my new coordinate for x coordinate is 1/2. And if you want, you can plug it in for x and just double checking that I indeed am evaluating f of 3, because again, that's the only thing I know. And that ends up being the case. Now for the y coordinate. Well, it follows the order of operations because coming out of the f function will be -5, my original y coordinate. I'm going to multiply that by -3 and add 8. So it's going to be 15 plus 8, which is going to be 23. So my new point is 1/2 23. So here's a point. Where does this point go given the transformation? All right, let's talk about another type of problem. Let's talk about a similar idea. So let's say let f of x have domain -2, 7 and range, let's do -5, 3. Let's find the domain and range of the following. Okay, so let's do a few of these. 2f of x minus 3. Maybe I'll do +1. Okay, so for the domain, you want to figure out, based on this transformation, what's the new domain? What's the new extremes here? And I might notice here that, okay, this means I'm shifting everything to the right 3. All the x values are shifting right 3, or my graph is shifting to the right 3. And you could do that to each extreme. I like to put whatever's inside that f, or whatever the function is, between the extremes of my domain, because then I can take care of this all in one step. So if I'm shifting right 3, that means I'm adding 3 to both extremes. And my new domain becomes 1 to 10. So that's the domain transformations. And then for the range transformations, the 2 means I am vertically stretching by the factor of 2. So I'm multiplying y values by 2 and then adding 1 or shifting up 1. So let's do that. So my original output was -5 to 3. I'm multiplying the y values by 2 first and then adding 1, following the order of operations. So I've got -10 to 6. Adding 1 to that gives me -9 to 7. So that will be my new range, -9 to 7. Okay, let's do another one. What about, this one's going to be tricky. Let's do -2 f, let's do an absolute value of -2, absolute value of f of -x plus 1 minus 3 plus 7. Okay, there's a few things going on here. So let's first hone in on what is affecting the domain. And that is what is inside the function here. So -x plus 1. And if I think in terms of graphically, remember reverse order of operations, this would be shifting left 1 and then flipping over the y, or reflecting over the y-axis, flipping over the y-axis. But again, I think for me, I find it helpful to just put whatever's inside the functions between the extremes of the domain. And let's solve for x. So we're solving for our new domain. Subtracting 1. And then when I divide by -1, I'm flipping the inequality signs. And so I'm now going from -6 to 3. So my new domain is -6 to 3. Now for the range. Okay, so we've got to be careful here. This absolute value in the range can be confusing. So coming out of this function, if I found my new domain correctly, I should be getting my new range here, or my original range rather, of -5 to 3. Okay, so the first thing I'm going to do, remember order of operations with range, is I'm going to subtract 3. So working from that original range and subtracting 3. So that would give me, so I've got -2 absolute value. When I subtract 3, I get -8, comma 0. You know what? I'm going to change this because I want to have a point here. I want to show something. I'm actually going to change it from being -3 to, oh Lord, that eraser's not working. Let's just change it to -2. Again, you're going to see. I just want to make a point here of why. Okay. Sorry. So I'm just changing. It didn't affect our domain transformation at all, but I do want to show something with the range. So if I subtract 2, I get 1. Okay, so we're going to be taking the absolute value of those range values. So this is where people tend to get confused, because absolute value in general, if we're just talking about a single number, if we take an absolute value of a positive or 0, the absolute value doesn't do anything. If we take an absolute value of a negative number, the absolute value makes it positive. So if I think of all y values ranging from -8 to 1, when I do the range transformation, like the absolute value of the range, that means everything 0 to positive stays the same, and every negative y value becomes positive. So say we had some graph here that right now, for now, I'm having this range of -8, and the highest y value right now is, say, 1, as we have here. Well, when I do the absolute value of the range values, the lowest now is going to be 0, and the highest won't be 1. The highest will be this -8, which now becomes +8. So don't just think of doing the absolute value of the individual extremes. You really want to think, okay, if I have values ranging from -8 to 1, what is my smallest y value coming out of there if I'm doing an absolute value? And it would be 0. And the highest in this case would be 8. And then I'm following the order of operations. So 0, -16. So -16 comes first, 0, plus 7. And this will give me -9 to 7. So that's my new range. So just be careful with the absolute value in the range when you're talking about a range effector. It makes 0 and positive y values stay the same. Negative y values become positive. Okay, let's do one more type of problem, which is, let's just do a graph. Okay. So let me just create a simple graph here. All right, so let's do, all right, I don't know. So just create some points here. And maybe I'll have it going down. No, I don't want to do that. And let's see. Let's do like this. And that, and let's just do something like that. Okay, so here's a graph. We'll just call this g of x, and I'll ask you to, how about sketch a graph of -g of -x. Okay, so I find it helpful just to write down the transformation first. So there is a domain transformation. This means all positive x values become negative and all negative become positive. In other words, reflect over y-axis. And the negative outside deals with the y values, which is going to be reflect over x-axis. Okay, so and I find in something like this, it may be easiest to go point by point. So if I take this first point here, which is at 3, 0, this first point to the right, the domain transformation brings the point to -3, and then the y value, -0, is still 0. So that point will come over here. The next point, if I look here, this is at 2, 3. Well, now it would be at -2, -3. The y-intercept is 0, 1. Reflecting over the y-axis, it's still at 0, 1. But then reflecting over the x-axis, it goes down to -1. And then we've got the point at -2, 1. That becomes 2, 1, but then 2, -1. And the point at -3, 0 becomes 3, 0. And lastly, -4, -1 becomes 4, 1. So we've got this graph here. It was reflected over both axes, which hopefully you recognize what happens when we're reflecting over both axes. So it looks reflecting over the y and over the x-axis here. Okay. Let's do one more here because this can be confusing, I feel like. What about if I asked you to do, let's say, the transformation g of 2x minus 1. Well, let's write out what would I do for each point. There's only a domain effector here. There's nothing outside of G. So this means the first thing I'm going to do, remember reverse order of operations, is shift right 1. And then I'm going to divide each x coordinate by 2. So that order matters. So it's shifting right and then a horizontal shrinkage. So the graph should look more horizontally shrunk or smushed. So let's just do a couple points here. If I take this rightmost point of the original graph, so we're looking at the blue graph, move it right 1, I'd be at 4, 0, and then half it, I'm at 2, 0. If I put the point, this next point here, I'd move it right 1, which is at 3, 3. Well, half of that would be 1.53, so it would be over here. And then 1 would now be a half 1. So far we're looking like this. Shifting this point here, right 1 would be -1, and then half of that would be -1/2. Then we've got -2 would go to -1, and then the last one, -3, would go to -1.5. There we go. So it is definitely smushed. So shift right 1, and then half. Okay, so those are a little bit on some transformations.